What are waves? Are they the ones you see when you go to the beach? Or are they what you constantly do every time you say hi or bid goodbye? Your sun's light rays? Or are they what the machos do when they dance? Well, before this video turns into something we would not want to hear in class, get your notes and your pen for a funny yet fascinating lesson. So, waves by its definition are disturbances which propagate move through a medium. Waves can be viewed as a transfer energy rather than the movement of particle. A water wave, for instance, which consists of moving peaks and troughs. A peak is a place where the water rises higher than when the water is still, and a trough otherwise. However, a single peak or trough is primarily known as a pulse. Therefore, this chain of pulses make up a wave. But there's so much more to wave than what I just mentioned. Wave has plenty of characteristics too. The characteristic height of a peak and depth of a trough is called the amplitude of the wave. The vertical and horizontal distance between the bottom of the trough and the top of the peak is twice the amplitude. And this simply tells us that the distance between two adjacent troughs and two peaks are the same. This distance, which is a characteristic of the wave, is called the wavelength, with lambda as a symbol in meters. The wavelength is the distance between any two adjacent points which are in phase. We have discussed some of the simple characteristics of waves that we need to know. Now, we can proceed into some more interesting and perhaps less intuitive properties of waves. The first property of wave is reflection. When waves strike a barrier, they are reflected. This means that waves bounce on things. Sound waves bounce on walls, light waves bounce on mirrors, radar waves bounce on planes, and it can explain how bats can see at night and avoid things. The next property of wave is refraction. Waves change direction when passing from one medium to another. This change in the direction of wave is called refraction of wave. During refraction, velocity and wavelength of waves change. However, frequency of waves stay constant. On to our next property, interference. When two waves meet, they both try to impose their collective motion on the particles. This can have quite different results. If two identical waves, same wavelength, amplitude and frequency, are both trying to form a peak, then they are able to achieve the sum of their efforts. The waves are adding together to form a bigger wave, so in a case where the resultant wave is bigger than either of two original, it is called constructive interference. If one wave is trying to form a peak, and the other is trying to form a trough, then they are competing to do different things and thus they cancel out. Therefore, the sum of two waves can be less than either wave alone, and can be even zero, and is now called the destructive interference. Our last property of wave is diffraction. When a wave strikes a barrier with a hole, only part of the wave can move through the hole. If the hole is similar in size to the wavelength of the wave, diffraction occurs. The waves that comes through the hole no longer looks like a straight wave front. It bends around the edges of the hole. If the hole is small enough, it acts like a point source of circular waves. This bending around the edges of the hole is called diffraction. Mechanical. Moving peaks and troughs in any medium constitute a wave. And a wave has many kinds actually, and to name some, mechanical, sound, and electromagnetic waves are the examples. Mechanical waves, unlike electromagnetic waves, require the presence of a material medium in order to transport their energy from one location to another. While sound waves are examples of mechanical waves, light waves are examples of electromagnetic waves. It is possible to have waves where the peaks and troughs are perpendicular to the direction of motion, like in the case of water waves. These waves are called transverse waves, and the other is a longitudinal wave, having peaks and troughs in the same direction as the wave. Electromagnetic. Electromagnetic waves are waves which can travel through the vacuum of outer space and are created by the vibration of an electric charge. This vibration creates a wave which has both an electric and a magnetic component. An electromagnetic wave transports its energy through a vacuum at a speed of 3.00 times 108 meters per second, a speed value commonly represented by the symbol c. So, our video stops here. But don't you guys worry and start sweating the small stuff, because I'm pretty much sure that with a couple of topics we just discussed regarding waves and its parts, types and properties, I know you'll pass whatever test you'll have to face. You just have to remember the concepts, not facts. Do not memorize a thing. Try to understand them instead. And for sure, you'll do just fine.
Created using Powtoon.